Hi everyone, we are going to start chapter 6, and really we're not doing the full chapter of chapter 6. There's a lot of information in there, and in some ways I might just even jump over chapter 6 entirely, but there's parts of it that or at least a part of it that we have to have to be able to be successful in particularly chapter 8 coming up. So the piece of chapter 6 that we're particularly concerned with is using what's called the unit normal table. So in your textbooks, this is table B.1. So Appendix A is math review stuff, I think. Appendix B is where your statistical tables start. So the very first page of it, and it goes on for several pages after that. So this is what you're looking for, page 533 in the print book. And so what we need to do is learn how to use this table, how to work with this table. Well, let's start with just sort of looking at the things. Obviously, it's a table. Unit, we're going to take the curves, and we're going to break them into units, into pieces. And which kind of curves? Normal curves. So if you look at that table B.1, again, have this open. You're going to need this the whole time. What we see at the top here are three examples. All three are for normal distributions, for normal or bell-shaped curves. So if the curve we're looking at working with is not normal in its shape, in its distribution, then this is not a table we could use. Well, let's take a step back and look at this in probably a bit of a simpler way. Let's take a circle, right? It's a geometrically defined shape. Not the way I've drawn it, but it's got its own round perfection, right? So if I took this shape and I cut it into units, say, just eyeballing it, how much of the circle have I shaded? Well, a quarter of it, or 25%, or a proportion of 0.25. All different ways of saying the same thing. Well, let me add some more shading. Now let me shade in. Now how much entirely is it shaded? Well, I added another half or 50% or proportion of 0.50. So now I've got 75% or a proportion of 0.75 or 3/4 of it. All different ways of saying it. We know this because it's a geometrically, perfectly mathematically described shape. And if we put these lines, these dividers, if we break it into the correct size units, well, then we know what the proportions or percentages in those units are. I always like to imagine I've taken a pair of scissors and snipped the bottom of this curve open, or the bottom of the circle open, and just take those two pieces and stretch them out, and you've got a curve instead. This also is a geometrically perfect, mathematically described shape. The formulas for it somewhere in your book, I believe. You don't need to know it. You don't even need to go look for it, but it's out there. And so let's imagine I'm doing the same thing. Let's do the simplest one I can. I'm going to divide it into a unit, and then I'm going to shade. Well, how much of the curve have I shaded in? Half of it, 50%, proportion of 0.50. Again, three ways of saying the same thing. Okay, that's what we're doing with this table. With this unit normal table, what we're saying is wherever I put a line, I can look up. It's a matter of looking it up in the table. Well, what percentage or proportion is in that shaded spot? So that's what it does. And where do we know where these lines are? We're using z-scores. Remember, a z-score tells you a precise, exact location in the distribution. So if I know what the z-score is and I drop that line, I can look up in the table to see exactly what proportion is in that section or in the other section or any other section. So take a look at your table. Again, you're going to need it. Once we get done with chapter 7, there's not going to be another chapter again for the whole rest of the semester where you don't need to use some table from the back of the book. They all require the use of these tables. So this is just the first one we're learning. Now take a look at it, and one of the things you'll notice is that the table really is a set of 4 columns running down each page. It's 2 sets of them. So you've got column A, B, C, and D. Column A is labeled Z. That's your Z-score. That tells you the exact location on the curve you're working at. B, proportion in the body. If you look up above, it gives you two examples. Pretend those are symmetrical normal shapes. And it cut it this way on that first one, and it cut it this way on that second one. The shaded area there is the body. It doesn't matter if it's on the left side of the divider or the right side of the divider. When we cut our curve into two pieces like this, there's a body and a tail. The body is the bigger piece, the tail is the smaller piece. So in this first one, we've got the body on the left and the tail on the right. On the other one, we've got the tail on the left and the body on the right. So column B tells us the proportion of data, the proportion of the scores that are in the body. How much is in the shaded section? C tells us the proportion of the curves, the proportion of the scores in that curve. Because remember, this is all built out of scores, right? So column C tells us for the tail. Well, what's the proportion in the smaller piece here? And again, it doesn't matter left or right. Bigger piece body, smaller piece tail. And then you see column D is a little bit different. It's a little bit odd compared to the other two. Instead of saying proportion in the body or proportion in the tail, it says proportion between the mean and a Z-score. So if you look up again at the top of that, the far right-hand one, the far right-hand example, you see a curve that's got the mean and it's got a Z-score plugged in there, and it's the proportion in that stripe. You basically can always tell if you need to use column D, because if we look at this, we really have cut this into three pieces. 1, 2, 3. If it's cut into three pieces, however they're arranged, that's probably needing column D. If it's just cut into two pieces, like over here, then that's column either B or C in most cases. So what this means then is that we can take a Z-score, drop it in on a curve, and then know exactly what proportion of the data, what proportion of the scores exist either above that line or below that line, either in the body or in the tail. And then again, same thing here for D, that we can get the exact proportion in that stripe. We'll see that we can also then go the opposite direction. So we can use the Z-score to figure out what the proportions are, or, and what we'll do actually more often in the course, is set the proportions first and then say, okay, what Z-score drops that boundary? So we're going to work on both of those types of problems. I'm going to give you lots of different versions of how to word these and what to look for. In all cases, a sketch is your friend. You don't have to, like we did in the last chapter, in chapter 5, you don't have to draw out a bell-shaped curve and put a whole bunch of standard deviation lines in it. We really don't need all those standard deviation lines. In some cases, they're going to be confusing. But making just as ugly as these sketches are, one of these sketches from the problem can keep you from turning a simple problem into a disastrous mistake. It's not that tough, but you got to keep yourself organized, and the sketch is a roadmap to victory. So, when we come back to the next clip, we're going to start figuring out and actually use the table itself.